Flood fill. All right, let's try this. This one says easy 20 minutes. I have 20 minutes. An image is represented by an m by n integer grid. Integer grid image where image ij represents the pixel value of that image. You're also given 3 integers, SR, SC, and color. You should perform a flood fill on the image starting from the pixel image SR, SC. Okay, to perform a flood fill, consider the starting pixel plus any pixels connected 4-directionally to the starting pixel of the same color as the starting pixel, plus any pixels connected 4-directionally to those pixels also with the same color, and so on. Replace the color of all the aforementioned pixels with color. Return the modified image after performing the flood fill. Are they going to define 4-directionally, or are we going to just assume that it means north, south, east, west? Up, down, left, right. I'm not going to look at hints. I saw a little thing that said hint. Show hint right there. It would be nice if there were a definition for 4-directionally, but this kind of explains it here, I think. The bottom corner is not colored 2 because it is not 4-directionally connected to the starting point. So here's the starting point. So I'm assuming that these 4 directions are up, down, left, right. I don't think that's an invalid assumption to make. All right. Let's start off by npm source lib. The problem number is 733. Flood fill. And then we'll use ::star. Grab this. And then we'll paste in copy, oops, paste. And then we want to just return vec new to make sure this compiles. It does, and then we'll write a test, mod test ex1. Okay, so now how do we want to define these? I guess I could just create a vec of a vec, flood, fill, vec bang. If I copy paste, then we just have to insert the vecs in there, right? And then SR1, SC is 1, and color is 2. And then the result should be equal to vec bang. And I gotta put more vec bangs all over the place here. I'll do that now. Search for open square vec bang. Yeah, I think that should do it. Let's see if that builds. Okay. So the left, so we returned an empty vector and we were expecting this. Perfect. All right, so I think we're all set up. Flood fill shouldn't be that hard, right? What we can do is we get the color that we're replacing, right? We have to read that out of the array. Let's call it the key color. It was row column, right? Yes, SRSC. So that's the way we're going to do it. And right now, I'll just return vec new, and we'll print out when replacing key with color. Oh, right, usize. I'm going to have to do that everywhere, aren't I, as I go through this. Oops. Okay, so it says replacing 1 with 2. Okay, so that's working. So we want to return a modified image after performing the flood fill. Are we not going to modify this in place because this is not mutable. So we're going to need to result is equal to image clone. We'll just clone the whole thing because you can clone a vector of vectors. Kafka says, but we own it. So we can write to it and then return it. Let's see. Image of SR as usize, SC as usize is equal to color. Yeah, we can't bar that as mutable. I'd have to put mute in front of it, and I guess I could change that, right? But I want to leave the function signature alone. And I can say result. Yeah, Kafka says you need to change image to mute image at the top. So I probably could get away with that. I don't know if they force us to use their function signature or not. I don't know. I mean, we could try it. Kafka says it's still the same signature. All right, well, let's try it. And then if it doesn't work, we know how to fix it. We could just clone the image. All right, so this now should have changed the center one to the correct color. Right. So it was 110, and now it's 120. So that works. Kafka says the signature is only concerned with types, not with the parameters. All right. So we'll do this. So now, what do we need to do? We need to loop over the entire image and look forward directionally between, yeah, okay. So we can do that. So we know the width, the length and the width. So let width is equal to image of 0 is 0.len. Height is equal to image.len. So I think the way we want to do this is by creating a stack, which is a list of positions. And we'll start off by pushing onto the stack the current or starting position, which is SR and SC. And then while let sum position is equal to position list pop. And then what we'll do is as we're searching through the image, we can push onto this list. Let's change this. So the first thing we're going to do is we're going to look up, down, left, and right. But we have to clamp it by width and height. So the one to the left is equal to position.0, which is the row. And then, now this is a U32, yeah. So we can go negative. We can say 0.max of position.1 minus 1. And that way, if we're on the left edge, we won't go any further. And this is pos 0 and then pos 1 plus 1 dot max of, no, dot min of width minus 1. And then we do the same thing for up and down. Zero minus 1, and then pos 1, and then let down is equal to pos 0 plus 1 min height minus 1, comma, pos.1. Okay, then we can look for row, comma, col, in, left, right, up, down. So we're going to look forward directionally, and each one of these are the U32, so we have to convert those into index. If our image at row as usize call as useIs is equal to the key color, then we're going to push onto our list row call, because now we have to search this location, and then we're going to set the result row as useIs, call as useIs to the new color. I think that's all we need to do. Is there anything else? What else am I missing? There's probably some edge cases that I'm missing, but let's see. Oh, right. So these guys are useIs as I32. Result. My brain was still on result, wasn't it? Kafka says you need to fill the first pixel still. You're right, I do. I'm not doing that anywhere here. I guess we got lucky in the fact that when we came over here, I flood filled it to the right. But you're right. That first pixel needs to get flood filled right off the bat. So we can just say image sr as usize, sc as usize equals color. And that should still work. But we just got lucky because if this was the only pixel that was going to change, that we would have missed that. And that actually should be one of the tests, right? So let's write a test that does that. One pixel. And we can just copy this and say flood fill, and we'll change this 1 to a 4. And I change this to a 9, I guess. And then we should be expecting result vecbang 111, because we're not changing any of those. Vecbang 190, vecbang 101. Right? Also, let's hope key is not equal to color, says Kafka. R-E-S-U-L-T. Yeah, okay, so that works. Right, so if key is color, let's do that test. So that's obviously a bug, since you pointed it out. Same color. It should not flood fill. If it is, if we flood fill 1 with 1, it's going to work its way around. It's going to do a flood fill and never end, because the key is always equal to the color. So we should be able to see an infinite loop on that one. I'm going to quit out of this now. But let's try that. Let's change that to 110, and then we'll change it to the flood with 1, and it should be equal to unchanged. Right? But I think it's going to be an infinite loop. Cargo test flood. Yep, that's an infinite loop. Okay, so that's easy to fix, right? If key is equal to color, or return image. Boom. Okay, so we can bake in again. Yep, perfect. All right, so let's try submitting this. Let's see if we made the mute change already. Let's see if we can do this. Tab. Submit. All right. Kafka says, I don't expect it to be in Leetcode. Well, we can try it. Let's try submitting it without this little blob of code and see if they have a test case for that. Memory limit exceeded. That's an interesting one. Yeah, so they do. So they had a 2x3 array changing 0 to 0. starting at 0, 0. And that failed memory limit. I didn't realize that would happen. But yeah, it's probably because we kept pushing entries onto the position list, right? And just never ran out of... never stopped adding things to the positions. All right, 10 milliseconds. It was 4 milliseconds the first time. See, this varies wildly, doesn't it? So I don't trust this runtime thing at all. All right, we got this done. Git status, git add source, git commit -m, problem 733, flood fill. So they estimated 20 minutes for that, and I think it took about 15. So that's not too bad.